माइक्रोफोन बंद करो.
Hello. अभी आपसे जो Hi. So I think delayed by 10 minutes. So good morning all. I'm Pradeep Chauhan, Managing Director from Geodesign Research Private Limited. You all are welcome. This is the very first session of sharing know-how. My request is, see, basically there are 3 sessions today, but then instead of 3, I would like to cover all that 3 into 1. Reason is that right now we have not been linked whiteboard along with this. And with me, Mr. Gautam Dahiya will also join to explain certain things into a depth. What I would like to cover is the basic conceptual know-how about the surveying. What is surveying? Why it is required? So you are all civil graduates or diploma, and you are already knowing that, and you have studied surveying to a level 1, level 2, might be in advance. But still, there is some gap between during execution, before execution, and on completion. What is the need of the survey? And what are the latest trend? What are the latest equipment? And how it has been correlated? So before starting that, I will start with the this window you can see on the so then there is a okay. So this is introduction. Let me make it full screen. I think. आखी स्क्रीन नीचे रोल था वीडियो ना there is a time lapse. Mouse is okay. So instead of going for definition, all you are knowing that surveying is the science or art to determine the position of point on or beneath of the earth's surface and locating that into the field. Now, category of surveying. So it's a plane surveying. Okay, then geodetic survey, where we are considering curvature of earth into consideration. Plane survey, so we are not making any correction for we are assuming that it is a flat horizontal surface. So earth is not a flat, so that is a curvature. So the perimeter of the earth is approximately 40,075 kilometers, and radii would be somewhere around 12,700. So looking to all these things, let's go one by one. So what are the different methods of surveying? So one is the photogrammetry, where if you are taking pictures and then from the picture you are analyzing that what point is the nearest and what point is the farthest. So this is nowadays the satellite pictures and the Google pictures. You can have this data, but the accuracy level in terms of depth would be minimum, and in terms of horizontal coordinates might be northing easting or might be UTM coordinates. So you will find difference into that. Another is the boundary surveying, is where we are establishing different property, their corners, their boundaries, and area of the land parcels. So you might be knowing that you during your education, matlab, you have studied about the traverse survey, then making completing that errors in the all different corners, and thereby you are making survey. Another is a control survey, where you are establishing a network of horizontal and vertical monuments that serve as a reference frame for other survey projects. So here what you are doing, you are dividing entire area into coordinate horizontal and vertical coordinates, that is X and Y. And thereby, say for example, you are establishing 100 by 100 meter pillars grid. So in between, whatever the things are coming, as all the four corners are known, so you will be easily reduce your structure or building within that framework. So it is a control survey. There is engineering survey, which provides points and elevation for building and civil engineering projects. Topographical survey, where we are collecting data and preparing maps, where the maybe a natural man-made, maybe plants or something, an elevation of those points and ground for the multiple uses. Route survey is a linear kind of survey where we are topography survey for a long and narrow projects associated with civil engineering. Might be different highways, roadways, then pipelines and transmission line, where there is a right of width or right of use. So limited width is there and length is quite high compared to width. And we are taking all those strips, and then we are placing our road, rail, considering all horizontal curvatures and then gradients and everything. All that geometry we are setting within that framework of the route survey. Then hydrographic survey. So again, where we are mapping soil lines and bottom of the water bodies, it is also known as a bathymetric survey. Okay. So using that eco sounding, we are measuring different depth in the pond or river or in sea, and we are trying to get the contour or line of equipotential underneath of the water. So it is more commonly known as a bathymetric survey. So when you are designing jetty or you are designing any offshore onshore structure, so bathymetric survey is very much required. Other than civil engineering, for the transportation of large size vehicle, so we need a channel into that. So sometimes silting and deposition of the underneath of the bed in sea. So that will also create a lot of problem for transportation of these vessels. So bathymetric survey is also required on a regular interval for that. Another is the astronomical surveys, so where absolute location and direction of any point subject to sun or any other star. So this is all comes into the advanced survey. And sometimes people are also using for prediction and all that vastu, relevant to star and rasis. So let's go to the basic things. So the coordinate system. So you all are knowing about the coordinate system. Today I don't have whiteboard, so I can explain you. But if you will see, this is X, Y, and Z coordinate, and over here your point is X, Y, Z. So in X-axis, this is the distance. In Y-axis, this is the distance, and Z is the altitude. So this is the distance. So it is known as a polar coordinate. There are 4 quarters. So this is a quarter 1. This is quarter 2. Quarter 3 and quarter 4. In quarter 1, X and Y both are positives. In quarter 2, X is minus and Y is positive. In quarter 3, X and Y both are negatives. And quarter 4, your Y is negative and X is positive. So this is known as a rectangular coordinate system. The another system is a polar coordinate system. So over here for the same point, if I am connecting with the origin, so whatever the angle formed with X-axis is known as a theta. And this diagonal is the radius. So it is known as a r theta. So r theta is a rectangular polar coordinate for 2-dimensional thing. And if it is 3-dimensional thing, so the same point. So here the true angle with the YZ plane, true angle with the XZ plane. So it is known as the theta and phi. So this point is at a from x-axis, it is certain angle. So this is known as a theta, and from y-axis, it is at an angle. So it is known as a phi. So it is known as a delta, theta and delta. So the radius r theta phi. So this is known as r theta phi is the again polar coordinates. And if you will see any Google map, so you will find two values into that. So that is easting and northing. So the first is a, if you will see the first 2 or 3 digit, so it is all angle, their angle. In the longitudinal, it's a longitudinal coordinate varying from 0 to 180 degree and another 180 degree. So that is known as the longitude towards easting. Okay. And similarly, the other dimension is, I'll show it to the picture also. Yeah. So this is a longitudinal and this is a latitude. So this is a theta and this is phi. So you can see into the picture. So this is a geographical coordinate system, also known as the polar coordinates. Another is a UTM coordinate. So in UTM coordinate, we are dividing entire Earth into different zones. So there are 20, there's a zone known as starting from A and B. On the South Pole, we are neglecting that, and we are starting with the C. So right from C to W, X, Y, Z. Y, Z again has been neglected on the North Pole. That circle has been omitted. And on the top, there is a deviation of 6 degree from the center of the Earth. And from bottom side, it is about 10 degree. So if you are removing 16 degree out of 180, so you will get 164 degree, 64 degree, and that has been divided into all this trapezoidal. So can you see this trapezoidal? This is one trapezoidal is known as a one zone. So for example, it is a T, and this is a T zone, and this is 31 number. Or you can say this is N31, this is N32. Likewise, this is R31. So each zone has been assumed that it is a flat. So it is a like a parallelogram, or you can say trapezoid, where the bottom width is more, the top width is less, and both two sides are equal. And approximately at equator, this is about 666 meter. If you are going at the top, so this dimension will reduce to almost 117 kilometer in the one block. And if you are coming down, so it would be on the top it is 70 kilometer, on down it is 117 kilometer. And over here at equator it is 666 kilometer. In terms of vertical dimension, it is approximately about 900 kilometer by 900 kilometer. So each of the point, each zone, so this is origin. For this zone, this is origin. So this is towards easting and this is towards northing. And that coordinate, this will won't be a zero. There is some assumed figure given in the zone, and from that zone, this is measured towards easting and towards northing. And this is in meter. So earlier coordinate that geographical coordinate, that is a polar coordinate. So it is in r theta phi, and this one is the UTM coordinate. So nowadays, when you are measuring survey using all that advanced method, so all that coordinate we are getting in UTM coordinates, from that we are reducing to local coordinate. Because in local coordinate, we are assuming that it is flat, whereas the UTM coordinate comes with the curvature of the earth. So that corrections are required. Right now, today, I don't have whiteboard, so I won't be able to draw pictures for the further explanation. But first, let's try to finish this, and gradually we will try to I'll try to sketch something which will be more elaborated. So, might be knowing chain survey, and chain is out of day now. But in earlier days, there was a chain, then there is a label, and there is a theodolite, So now even the theodolite is no more in the practice. Nowadays, all that electronic distance measuring system where we are using all that LIDAR laser beam for measurement of the distance, might be a single beam, might be a multiple beam. It is also known as a LIDAR system. Then total station. So again is a advanced version of the theodolite, but it all comes with all electronic measurements and everything. And once you are leveling that equipment, and if you are pinpointing any reflectory surface, so then that measures straight away distance and convert that point into X, Y, Z coordinate. So in terms of longitude, in terms of latitude, and in terms of altitude. All that measurement can be made using total station. Hmm? Manage करवा पड़ता है. So now, so we'll see that also into detail. So it's all total station. GPS, so global positioning system. This I will explain you in detail. But let me explain you in a line. Then there are so many satellites moving in the space. Might be US satellite, might be Russian satellites, and nowadays Indian satellites are also there. So whenever there are receivers and transmitter, or you can say rover and base. So where we are receiving the signals, okay, at a certain frequency, L1, L2, from my satellite, and that is receiving that at a certain speed, about 4,000 meter per second, and that position of your GPS, that is a base or rover from satellite, and then making correction. So it is getting its own position, stationary position, from different satellites. Might be Galileo, might be other. So there are so many satellites moving in the space. And if you are keeping that for a long time, it is known as a static survey. Okay. Because you are keeping for a long time, so it is more and more average value will come for a longer duration of time. So you can define the position of that particular point in X and Y direction very precisely. And Z is the altitude. So how X and Y measures, or from where geographical measurements are being made. So there is a prime meridian. I think let's forget chain or all this thing. I will try to eliminate all those things which is nowadays of no use. Okay. So these are the satellite moving in the sky. This is my base. I am getting my position from different satellites for a certain time, and making average thereof, I am knowing the position of my particular pin in the world where it has been situated, either from prime meridian or into a UTM coordinate. UTMs are the segments. So your GPS system is comprised of the three segments. One is the space, where a lot of satellites are moving. Ground, we are using base and rover for collecting data, and we are the users. Now, who could be the user? So let's say in space, there are 31 active satellites which are useful for the navigation and measurement for the GPS. Then there are 6 orbital planes which are inclined at 55 degrees, 12 hours of orbital period, 20,000 kilometer high. That is the elevation of those satellites. Velocity is about 4,000 meter per second, and 24-hour 3D coverage across the worldwide. So there are certain terms which you might be feeling that you are not used to. But our basic idea is to understand now how we are measuring, or what are the advancement in the survey, and how it is working. Okay. So in ground segment, so again, these are in Colorado, USA, then Hawaii might be certain islands near USA, then Ascension, then Diego Garcia, and Kwajalein. So these are the location where they are determining the position of satellite and their predicted path, which is very much useful for the rest of the all user because that controls all coordinates. So you can see this is Hawaii, then this is a Colorado Spring, then this is a Ascension Island, then there's a Diego Garcia, and there's a, so it has been well spread in the sea, 1, 2, 3, 4, and 5. So almost at an equal distance nearby. So that all red color is the master control is at the Colorado, and others are the ground antenna and monitoring system, blue dots. A user segment, that is us. We are using all this facility, and there are millions of users worldwide. But so far as the civil engineering is concerned, other than civil engineering, we are surveyors or civil engineers. Scientists are also using this. Then fishermen are using this. ISRO is using this. NASA is using this. All pilots, that aviation sectors they are using. Soldiers are using, and then mappers making map of any town, city, country. So that those are the essential things for the GPS. In GPS, there are different kinds of signals, time codes, that data, and then other almanac information. Okay, so that is a signal. These are technical terms. So they are normally satellites are working at two different signals. One is at a 1575.42 megahertz, another is 1227.60 megahertz. And what are the satellites which is giving signals at L1 or L2? So that again, if you are really interested to penetrate more into that, you can always contact our surveying head and GM, Mr. Gautam Dayal, okay, because he is having the sound know-how and he is nearby me. But right now, I am delivering a lecture. Later on, if you do have any question answer relevant to anything, you just drop a message, a mail, okay, on given contact email ID and phone number, and definitely our team will reply to that your query to satisfy you. In GPS satellite signals, there is a combination of two. One is a carrier phase, okay, and another is a code phase. Code phase is a precise thing because there is a value 0 or X. There is a value 0 and X, and this is a variable. And combination of that two are the L1 and L2 signals. So again, this is a satellite position, this is a pseudo range, and this is a computed range at the ground. Okay, we won't penetrate much into that, but then whatever the correction due to pseudo range, because that signal comes at a velocity of 4,000 meters per second, and whatever may be the time in microsecond, if you are multiplying that, so that gives you a distance, and that distance we are considering is a kinematic because your satellite is also moving, your Earth is also moving. So there are a lot of corrections are required to that distance, and thereby we are trying to know the position of ourselves at what XY coordinate or northing easting we stands and at what altitude. So for any three-dimensional position, we should have at least minimum 4 satellites data should be available. And again, type of satellites are also important. Some of the satellite has been prepared only for the purpose of GPS, like Galileo. Okay. What else are?
Recently, India has launched its Gagan.
Gagan. From India, we have launched one Gagan satellite. So this kind of, if the satellites are mainly for this purpose, so the accuracy level will be high. And if there are other satellites for other purpose, they also gives you position. But then what weightage we should give to Galileo and Gagan, so definitely it is much more higher than other satellites. There are measurement errors which need all kind of correction, inaccurate clocks, then satellite orbits, then measurement noise, then there is atmospheric delay, then there is a satellite geometry and multiple paths. Even the reflection, sometimes that you might be getting signal which has been strike to some reflectory surface like vehicle or tree, and then it comes to you. So then that required lot of processing using software at laboratory level, and then it has been corrected. So these are the kind of error, okay, measurement of noise, then multiple paths. So here one is coming directly to you, and another has been reflected through trees or something, or some vehicles. So all those corrections are required. And nowadays there is no tension because the LIDAR system and everything measures millions of measurement at a time. So that is theoretically giving correction is not feasible. So there are a lot of softwares available for giving correction for and converting your coordinates from northing easting to UTM coordinates to local coordinates. And thereby we are getting all distance and angular measurements. So I think I won't penetrate much into this because otherwise what will happen? You will get bored and then see our basic topic is then what are the different methods of surveying and how we are utilizing that. So now, yeah, this is important. Our Earth is not exactly sphere. Our diameter of Earth at equator, this is at equator, is larger than diameter at prime meridian. There's a meridian, okay? Might be few meters, but then significance of that is difference E by B, and then there is a correction. So that we need to apply. This is A is my radius. Okay, you can see this is my radius in meter at equator. Okay, and for B, this is the correction. So they are all trigonometry and geometry. So again, I won't penetrate into that. See, this is our Earth. Yellow is our Earth. Not exactly this year. It has been highly scaled just to show that then there is a depression, then there is an enlargement, geoid, and there is just to give you understanding, GRS80, okay, WS84. In 1866, the Clerk has invented ours is a this elliptical mass equivalent to Earth mass. This is the dimension. And later on, with the all advanced measurement, now this is the measurement, which is which we are using for conversion. So all that correction is required. You are coming from this point to yellow surface. Okay, so these corrections are required. And how the correction has been given to XY coordinate, that is longitudinal and latitude dimension, as well as height. So they are all theory behind that. So again, we won't penetrate into that. But yes, I would like to say the XY position or northing east is very precise, whereas the altitude is always measured from the mean sea level. And then earlier the zero level has been measured at a certain temperature, as a certain day on low tide, high tide, that is at Karachi. Now it has been reduced to Bombay High. And nowadays we are using that as a zero. And whatever above that mean sea level is positive dimension in meters. And whatever we are penetrating below that, either into sea, so that is in a minus level. Okay, so that is the altitude. That also, if you will see, check the Google Earth or then Google Map, you will find X, Y, and Z coordinate. So that is Z is the height from mean sea level. So for example, Baroda. So Baroda is about in a range of 40 to 60 meter. So from sea level, we are at 40 to 60 meter above. So whatever the rain falls, so it goes towards the nearest zero level, towards the sea. And whatever the distance, say approximately our nearest sea is at Khambag, which is about 55 to 60 kilometer, and this 40 meter is my height and 60 kilometer is my length. So again, 60 kilometers is a straightforward distance, the aerial distance. So definitely it will go through certain branches and from river and thereof. So length would be much higher. So for example, if it is 3 times, so in that case about 200 kilometer, and your deviation is 40 meter. So 40 meter divided by 400 kilometer, sorry, 200 kilometer. So the ratio is about 1:5,000. 40 meter divided by 200,000 kilometer. So let me convert that. So it's 1:5,000. So most of the river, if you will see, the very old river will be at a slope of 1:3,000, 3,500. And if it is a too young river or in the hilly terrain, you might find 1:1,000, 1:1,500. Why this is important? Because if you are designing bridge, so you need to work out the highest discharge. You need to, if you are designing certain canals or then what are discharging system or some river training work. So all these levels are important. Okay, fine. So now GPS is the three-dimensional system and then there are all corrections. I won't find it because we need to manage within 5 minutes. Now survey. Again, whatever the remaining after 10-15 minutes of break, again we will start by around 1 o'clock. Okay. So, okay, fine. We will start with what is the triangulation survey. So in earlier days, when there was no other measurement system, there is hardly chain and compass. From compass, we are measuring angles. Chain, we are measuring distance. And we are making everything into triangle. As you rightly know, okay, then triangle is having area. Area is equal to 1/2 base into perpendicular distance, height. And other formulations for measurement of the perimeters is side A, B, C. So straight away total thereof will give you the perimeter. And area of the triangle where you need not require to go for the base and perpendicular height. So straight away take the perimeter divided by 2. That is A plus B plus C. They are the three sides of the triangle divided by 2. So it's the semi-perimeter. Okay. So let's say it is S. Okay. And your formulation is under root of S into a bracket S minus A, another bracket S minus B, another bracket S minus C. So the square root thereof will give you the area of that triangle. And thereby they were measuring all that project has been executed using chain and compass. But now, yes, after theodolite, we do a total station, we do have a DGPS system, then we do have a LIDAR also. So all these things we will see in the other lecture. Okay. So let's have a break over here because this is a very first lecture. And then today problem with me is that I don't have any whiteboard with me, but still my people are trying to manage that. Probably the next Saturday, we might be having interactive panel with us, so that problem will get sorted out. And we will go. See, if you will refer the calendar thereof, you might be having calendar with you. If you don't have, you can always ask from Balachandran, my PS, or Gautam bhai. So you just go through the sequence thereof. So then surveying is the topographic measurement. Then it will comes about, this is all about the surface. Okay, surface of the earth. The other part is the section of the earth. That is a geotechnical or geophysical survey. Okay, that is a soil investigation. So the next lot of lectures would be on the soil. And then planning of the road, planning of the building, then planning of other structures, the architect, that structure. So more or less it is in that sequential form. So I will request all of you, see, we are also trying, so this is a live demonstration or the live technical know-how sharing, but we will try to record all these things for future. So somebody has missed something, so they can always download from our YouTube channel and you can contact Mr. Gautam Daya for this. So let's have a small break and then again, 1 o'clock, we are meeting. Thank you guys.
हेलो ढैया साहब, आई एम लिविंग. चलो लेक्चर खत्म हो गया साहब का. प्रदीप साहब का
हो गया
रिकॉर्डिंग किया है ना पूरा.